All right, let's get started. Hi everyone, I'm Alex Vanyo. I am a software engineer at Google working on the Compose team, and today I'm going to be talking about handling configuration changes in Compose. So if you're coming to this talk and this is the answer that you're trying to find to this question, what should you put in Android config changes? That is this talk. I will give you an answer to this question, but not yet. I want to set some groundwork, go through some definitions, get on the same page before I actually give an answer to this. So let's start from the beginning. Configuration. What is configuration? Why do we care about it? What does this talk about? Configuration is kind of generic. You have all sorts of different configurations you might be interested in. But in Android, specifically, it's configuration.java. There's a whole set of device and user-specific configuration values that are in configuration.java. These are things like locale, density, window size, font scale. There's a whole bunch of these that describe kind of the overall configuration for your app to render UI. And these aren't fixed. These can all change at runtime through user settings, rotating, unfolding. Everything that you do to an Android device can change its configuration. And this is important because another very related concept to configuration and configuration changes is activity recreation. Now, these two things are not the same thing. They're very related, but I want to put a difference here and put a difference in your mind of not referring to these things as the same, especially once we start actually changing how they relate to each other. So their actual relationship is that configuration changes cause activity recreation. By default, when a configuration change happens, your old activity is destroyed and then recreated with the new configuration. And I want to take a step back too and just ask why. Like, this is the way it has worked and has always worked, but why? Why recreate the entire activity? And, this sort of idea, this concept, this behavior is like one of the main reasons that architecture even exists as a concept. Like probably one of your top 5 reasons to have an architecture is dealing with Android component lifecycles. There might be some other reasons too in there, but dealing with the Android component lifecycles is a big one. And the answer to this question is resources. Basically, configuration determines what resources your app is using at any given time. So when you qualify resources for different configuration values, you get different resources based on the configuration. So when the configuration changes, the qualified resources change. And therefore, we need to use those new values so we can throw away the entire activity and recreate the entire UI to guarantee that we're using all those new resources. This works. This is a way to make sure that you use all the new resources when the configuration changes, because that might change which resources are available. But that's not the only way. That's the default way, but that's not the only way. Like I mentioned, configuration changes by default cause activity recreation. And this is a thing that you as an app developer can control. Specifically, there is an Android config changes manifest value that you can add, and instead of causing recreation, then these configuration changes will instead cause your on-configuration change callbacks to be called. So let's look at what that looks like in your manifest. So your activity Android config changes, by default, it has nothing in here, which means that you'll get the default behavior where configuration changes cause recreation. You can put things in here like locale, you could put in things like density, and there's a whole list of these that you can put in. You can also put in multiple at the same time, and you can specify that with like the pipe operator to say that these are the set of configuration changes that I'm opting out of recreation for. And here's the full list. As of Android 16, these are all the different configuration changes that are available that you can opt out of. I want to highlight, because Android 16 actually added a few new things that you can put in here. The first one is that first one in the list, assets paths. This one controls things that are resource overlays, like the background. If you know about the configuration change that's being caused by a background wallpaper change, previously, up till Android 16, you couldn't opt out of it. But now, in Android 16, this is a new value that you can add to opt out of that configuration change. There's also a new tag called all-known. This one is a special kind of meta tag. This one will expand itself out to that full list that you just saw. So with AAPT2, it will compile that all-known out into the full list of everything that is known at that time. And specifically, this behavior means at this time, at Android 16, it will be this list. maybe we'll get to Android 42, and there'll be a new configuration change type, life of the universe and everything. Then what all known would do is once you are on Android 42, compiling at that level, it will then compile to this new list as new configuration changes come out. There is another similar but distinct tag in Android 16 that you can also put in here, which is resources unused. This is another new value that you can add, which will disable all activity recreation for configuration changes, past, present, and future. So what this means is, that if you put this tag in as of Android 16, then all those configuration changes that you just saw you'll be opted out of, and that app that you just built, if it runs on future versions of Android, it will also opt out of recreation for any new configuration changes that come out later, like maybe in Android 42 with that new life, universe, and everything one. One caveat with using this might be kind of a useful thing to put in, because resources unused is only recognized by Android on Android 16 and above. So in the meantime, before we get to Min SDK 36 for Android 16, in the meantime, you'll probably want to opt out of a bunch of them on older versions as well. You might try to do this. This won't work because all known is a special tag. Instead, what you want to do is put in all of them that we know of right now, and then add in at the end there resources unused. So if you specify this, you will opt out of all recreation for all configuration changes now and in the future. And that's this. So as of Android 16, with Compile SDK 36, it is now possible to opt out of all activity recreation for all configuration changes, known and future. But you can't opt out of all activity recreation. There are other reasons why your activity will be recreated. There's memory pressure and process death, in which case your activities will be destroyed, and then when the user comes back, you'll get a new activity that you want to maintain state for. And losing temporary permissions is another interesting one. If the user grants your app a temporary permission, then it goes in the background for a short while. When you come back, you will actually get a new instance of your activity. Your entire process will be killed. So this is another way where, using your app fairly normally, you might see that your app gets killed when the user comes back to it. But the user wants to still be where they were. To the user, they want to be right where they left off. Okay, so there's a bunch of new options in Android 16. I'll get to if you should use those and why. But I'm setting the stage here for thinking about configuration changes in kind of a new way. This is kind of the way it's always worked, but now this is actually something that you can think about. When a configuration change happens, you have two options. Either you can let activity recreation happen, or you can rely on the callbacks through onConfigurationChanged and handle those directly. And one thing I want to point out here is this is a choice you have to make and you have to handle as a well-behaving Android app for all these types of configuration changes. I think in the past, sometimes like, oh, if I opt out of recreation, I just don't have to worry about it happening. The configuration changes will happen. There are things that the users cause when interacting with the device, with your app. There's no way to opt out of configuration changes themselves, and you can't disable configuration changes. These are things that will happen. Your app does need to handle them. Otherwise, it's a bug. The user changed language. They need your app's language to update. They rotated the device. They need your app's layouts to handle the new window size correctly. They resize your window in a freeform windowing mode, like on a desktop display. With connected displays, your app needs to handle that window being resized. And this kind of gets to the point of what this Android config changes really is. When you specify something with Android config changes, it is a promise. And I don't think I can overstate it enough. Just putting something in there and then forgetting about it is not meeting this contract. When you put something into Android config changes, opting out of activity recreation, it is a promise. It is saying my activity will directly be able to handle and update itself correctly when this type of configuration change happens. So I've been talking about these onConfigurationChanged callbacks. Let's now look at what these are. There are some on activity, on view, on fragment. There are also some on application and service. I do want to warn that if you're using these, I'd be a little bit careful of what values you're reading from. And the reason for that is configuration is local to a specific window. An example of this is if you're in freeform windowing mode, different activities are going to have different configuration values because configuration encodes the size of the window. So there is no one configuration at any given time. That multiple activities running at the same time might even be multiple activities within your own app. So even within your own app, there might not be one configuration. So be careful about using the on-configuration changed callbacks from application and service, which are kind of distinct from any specific window that's showing UI. So going back to activity view and fragment, I want to zoom in now on the view on configuration changed. This is the callback that you get within the view, and I just want to take a moment to think about what it means to do this within a view directly. Let's say you're opting out of recreation, you're specifying Android config changes. What does that actually mean? Well, if you're handling this with this in a view, it means that when the window size changes, you might need to reload and rebind any qualified layouts, anything that's different based on the old to the new configuration change. You need to handle density. Maybe you need to reload every single drawable that you're displaying. Maybe you need to update the locale. Maybe the language has changed, which means you need to rebind every single piece of text within your entire activity to handle the new locale. Maybe there's a theme change. This might mean, going from light mode to dark mode, that you need to handle rebinding every single color that you are displaying in your activity. And the list goes on here. These are not the only ones. There's even more, like that entire giant list I showed earlier. These are all the things that you're promising to take on. So 5 years ago, 10 years ago, this is a lot of things to actually handle directly. It's kind of like to do this better, we need a system where we have a observable source of truth that will automatically subscribe to any of these changes, and then it'll propagate those changes to perform any needed updates when and if those configuration changes. And I think I'm describing Compose here. Compose makes this way easier to actually do because we can create an observable source of truth, and through composition, we can subscribe to all these changes, and it'll automatically propagate both to direct dependencies and any transitive dependencies for using the new configuration value. So let's take a brief look, actually under the hood, of kind of how Compose does this. Compose view is a view, and it kind of keeps around this configuration that's backed by mutable state. And then when the configuration changes, it will update the configuration with the new value. And then your content gets wrapped within a composition local provider that provides you a local configuration, which contains not only the current configuration, but it's a snapshot state backed observable object that you can use to derive anything from the current configuration and get updates when it changes. So that's what Compose is doing. And then your content goes inside of here. So this kind of gives us a blueprint of how to actually handle configuration changes in Compose without relying on recreation. And it's kind of a simple rule, actually. Basically, anytime you're using configuration values, it must be coming from a place that is backed by snapshot state to make sure you get updates to any time it changes. And you can either use local configuration.current, or you can use anything that's derived from local configuration.current. A short list of these that are derived from local configuration.current are local density, local resources, local layout direction, local font family resolver, and local window info. All of these are themselves kind of derived from the current configuration that you have in Compose to render stuff. So if you're using any of these, you should be good to go to get a configuration value and then do the right thing with it and update. But it's still a little bit more nuanced than that sometimes. So I'm going to dive into a bunch of examples now, and all of these are going to be wrong at first, and then we're going to see why and then how to fix them. So let's start with this. We are super simple method to get a string. We're taking the local context, we're getting it, we're then getting the resources, and we're getting the string from the resources. This looks pretty normal, this seems fine, but there's actually a bug here. And the reason is that local context.current itself is backed by snapshot state. But that next call, getting the resources from the context, that is a normal Android call. Compose has no knowledge of this. It is not backed by snapshot state, so this actually won't work if the configuration changes. Instead, what you can do is a new value introduced in the latest version of Compose, local resources.current. This gets you the current resources as well, but this one will update itself when the configuration changes, and then you will get a recomposition and you'll get the new string if configuration changes, maybe for a locale, and you need to update. This is also a lint warning. If you have local context.current.resources, hopefully you see that as a lint warning to replace with local resources in the latest version of Compose. Also, for this example, there's also a even shorter string resource, which does all this correctly under the hood, so you should probably just be using that in this case in the first place. Let's do another thing. Here, we are formatting a duration, and we're going to convert it into a string, and we're going to round down to the nearest tenth. So this looks fairly okay, but there's something kind of hidden here, and that is that string formatting is locale specific. So inside this format method, there's actually a hidden default that gets the current locale from java.util.locale. This is not any part of Compose. This is not snapshot state aware. So if you are using this and the locale changes and you're not getting recreated, this won't work because you won't get Compose doesn't know that it needs to recompose and update with it. One thing you could try is there's a locale.current within Compose. This feels like it should be a composition local. Unfortunately, it actually isn't right now, so don't use this one. What you should instead be doing is using local configuration.current and get the locales from that. Local configuration.current will update. It is snapshot state backed, so then this one will recompose properly, getting the new format without recreation when the configuration changes with a locale. Let's go to dates. Dates, based on the previous slide, you might also suspect what's going on here. Dates and formatting are also locale specific, so there's a similar issue here. To fix that, we can again use local configuration, get the locales from it, and use the right datetime formatter. So we're almost there, but there's also a bug here. We added in the configuration, but we didn't add it as a key to remember. So make sure that anytime you have a remember set up like this, you have the correct keys within your remember to recreate the formatter when any of the dependent objects do change. So that's time and date out of the way. Let's go on to another thing. With Compose, and you might be using interoperability with different Android views, maybe you have a super fancy view that you have that itself doesn't support handling all these configuration changes without recreation. A technique that you can use here is using a key on the current local configuration in order to kind of force recreating everything within there when the configuration changes. This is kind of like doing the recreation yourself if you need to. So this is a way to, like, if this view, my super fancy view, itself doesn't handle everything directly, maybe you don't control it, maybe it's something that you don't have time to update, this is a way to kind of force a recomposition, throw away the old Android view, get a new Android view whenever the configuration changes. And this is also a technique that you can use for any piece of Compose code that maybe isn't quite correct. You can use key on the configuration to kind of reset all the state. You could also do something more specific. So if there's only specific types of configuration you need to do this for, instead of using the whole configuration object, you could use specific bits and pull it out. All right, here's a more complicated example. And this gets into kind of the size configuration changes. And I want you to kind of think about what's happening here and also why it maybe isn't so straightforward when you just opt out of everything that you can. So we're going to set up a anchored draggable thing that can go from the start to the center to the end. There's kind of 3 positions that we can use. So we're going to set up an anchored draggable state. Its initial value is going to be at the center, and then we're going to put this thing in a box. This spacer is the thing we're dragging, so we're going to hook up with the modifier.anchored draggable, set up the right offsets based on the state, and then we are going to make sure we get the size in order to set the anchors for where our anchor draggable actually is. This is all pretty standard anchor draggable stuff. So we're going to get our draggable anchors and update the state with those endpoints based on the current size of the box. So we're going to put start at 0, center at halfway through, end at the end. That makes sense. So let's actually run that. So on the slides here, this is this code running. So here it is in the center. I can then drag it over to the left, drag it to the center, drag it to the right. But let's think about now when I'm going to resize this entire box. Imagine this is your Android application, and this is resizing the entire window. So if I'm dragging and resizing the entire window, I still want to have, start, center, end, and keep that consistent. But if I drag all the way over and then release it here, something strange happened. This box is now at the end. It's not at the center. Center would be over here. And if I drag it back out, now it went from the center over to the start. So this is actually kind of annoying user behavior. I'm resizing the window, but my state isn't being preserved. This worked with that code we just had with recreation. And the reason for that is we were throwing away the entire UI, saving it with remember savable, and recreating it. So then we were saving, we were at center, throwing everything away, reinitializing, getting the center back, and everything was fine. But without recreation, any of these kind of UI layer things might start to get weird behavior with it. But luckily, this is a fairly easy thing to fix once you know what's going on. So let's go back into the code. This is where we were updating the anchors to use the new set of anchors. And there's a hidden default parameter here, which when you are updating the anchors, you're also updating where the target is. This is the default, and what this will do is it will choose the closest anchor from the new set of anchors that we're passing in, based on the current offset. So this explains the behavior we're getting. When we're resizing down, if we are near the end, that offset ends up being closest to the new center, which results in this kind of inconsistency. So instead what we can do is we can preserve where the user wants to be and use state to target value. To when we're updating the anchors, instead of choosing the new closest anchor, we choose wherever the user just was to actually preserve their state. So that was a little bit nuanced in the weeds, but these are the sort of things to kind of think about. You might be operating right now in a world where you kind of assume recreation happens and kind of all your logic works within that mental model. Once you start opting out of recreation and things are happening at time, all these things are updating to your UI in place, which is both cool, but also just different than we're currently used to. And this is now the running code with that updated example. So we have left, center, end, and now if I'm in the center and I resize down, this will now stay in the center. We'll keep where the user was, which is a much more kind of intuitive user behavior as you're resizing a window around, keeping the state of what the user wants to have. All right, one more thing. How do you test all this? How do you actually verify, if you have a bug like this, write a regression test, make sure it doesn't happen again. And you can, in your tests, actually cause real configuration changes to happen, like rotating the device, resizing, changing locale through system settings. But all those things can be a bit annoying because they're device level configuration values. So one thing you can use is device configuration override. What this does is it actually takes advantage of this whole idea of having everything backed by those composition locals. So internally, overriding the locales will basically override what the configuration says the locale is, and then anything within there is trying or should be using that new value. So you can check your current language, then we can assign over, update our language to Spanish, and then if everything's working correctly, my app should automatically recompose to use the new locale. And then you can check to make sure that actually works, either directly or maybe with screenshot tests, any combination of that. So device configuration override works on this principle of making sure that all your compose code is being backed by observable snapshot values. All right, that's a whole bunch of examples of what's going on. Why should we do this? Why should we care at all about this? And why should we or shouldn't we add Android config changes to our manifest and opt out of stuff? So here's a few things. And I'm going to start with the one that has the biggest user impact, and that's state loss. So when you recreate the activity, you're throwing away your old activity, creating a new one. If you're not careful and you don't handle saved instance state, use view models correctly, you might lose a whole bunch of state within that activity, and the user is going to be really sad. I think everyone at some point has rotated their device or resized. They're filling out a form or something. You do that, and then you lose all your state. You have to do it all again. Ideally, everyone doesn't have this issue in your apps today, but I think the reality is that this is sometimes kind of hard. Using saved instance state sometimes can be really tricky, or in some cases, impossible. There are sometimes very complex or external components, like a web view, that you don't have full control over how it's managing its state internally. So a web view in particular, like it's an entire browser running in your application, there's a lot of state there. It can be really difficult to actually preserve all that, recreate it, and restore where the user was. Also, saved instance state itself has a size limit. So even if you're really, really good about it, and you're trying to save as much as you can, there's a limit to how much you can actually save. This is something you've probably run into as well if you've ever tried to put giant lists into saved instance state. So this is also a limitation. it'd be kind of easier if you didn't have to do all that serialization in the first place and you just didn't get rid of the activity. And this solves specifically an entire class of bugs for some configuration changes, specifically things like keyboard. So plugging in or removing a hardware keyboard or a wireless one with Bluetooth is a configuration change. By default, this will cause activity recreation. And this can lead to some really, really terrible user experiences where you plug in a keyboard and the app resets. You lost where you were in the app completely, it restarts, and you're basically like lost where you were. And then you disconnect it, same thing happens. This is really, really frustrating. Something like keyboard, I suspect most apps aren't actually caring about this at all. You're not having different UI based on whether a hardware keyboard's attached or not. So one like this might be a really easy one to just opt out of recreation for, and boom, that class of bugs is gone. Connecting or disconnecting a hardware keyboard suddenly doesn't recreate your entire UI. And I do want to emphasize here that this doesn't make save instance state or view models obsolete, just a little bit less critical. Specifically with navigation, you still need to be using saved instance state, still need to be using view models. The same sort of expectation applies when you go to a new screen. Your old screen state should be preserved. So when you come back to it, even though it wasn't rendered, you should still preserve everything. So this does not mean don't use saved instance state. Please still do. Still use remember savable. Still use view models. But for some of these like really complex components, this can be an easier way to avoid bugs that happen with recreation. Another thing that opting out of recreation and handling it yourself helps with is better performance. So it turns out that if you destroy your entire UI and your entire activity and then recreate it, that can cost a lot. I mean, imagine if you have an entire video renderer running, maybe some really expensive game engine. Like, it can be expensive to destroy that, recreate it. Updating in place can be a lot cheaper. Like everything with performance, make sure you're measuring it, verifying it, and not just going and like assuming that this happens. But updating in place can be a lot cheaper. Imagine you're in like a freeform windowing environment. Every time you resize, that's a configuration change. So as you're like resizing a window, you're going to get configuration changes constantly as the window is being resized. If every single time that happens, you recreate your entire activity, that's going to just feel bad. So better performance here can help a lot. Also, side note, that reason of resizing a window causing too many configuration changes, really janky behavior when you recreate a bunch, is the reason why there's actually that asterisk from before, if you remember, of by default, configuration changes cause activity recreation, usually. For size configuration changes, it kind of isn't quite every single size configuration change results in activity recreation. It's a little bit more nuanced than that. Okay, last one. And this is the most kind of like inspiring, there's a kind of a whole new type of thing that you can do with this once you are opting out of recreation and handling it directly, and that's animating it. So when you keep your old UI around and then the configuration change happens, you can animate that difference. So you can animate a theme change. If you're opting out of recreation for a dark mode, light mode, and that changes, you could just cleanly animate from the old colors to the new colors if you want to. And the one that excites me a lot the most is window size changes. So if the window size is changing, either freeform window, rotation, folding, unfolding, if you keep your old UI around and then you have a new set of UI, you can cleanly animate from that old one into the new one. So you could have some really cool animations here when like rotating the device, resizing the window, moving things around, maybe showing more panes or less panes as that happens. That is a whole giant, entire additional talk, so I'm not going to go into more detail there. But these are things that are unlocked once you are opting out of recreation and handling it all yourself. So, maybe you're convinced you actually want to do this. How do you go about doing this in a safe way? So, do one configuration change at a time in one activity at a time. This is a thing that's in your activity manifest, so do it. That's the kind of the smallest scope that you can do and change this behavior. It's responsible for a lot, so I'd go one at a time, adding it. Try opting out of it, and then validating that everything still works. In some cases, like those examples before, you might not quite have the right code to actually handle the change. So make sure you then fix that doesn't recompose correctly. Something that's also really important though, is once you make that change, and let's say you're committing that, and then your app is going to be opting out of recreation for those configuration changes, that means that starting then, all new code that you're writing needs to also handle that correctly. Otherwise, you're getting a new type of bug where you might get some of those examples where you weren't handling it. So when you opt out of configuration changes, this also means that you now have a new requirement for all of your UI code that you write in the future. And I would recommend starting with the least risky ones and the ones that have the highest benefit, and then working your way up from there. Don't just try to go all of them at once. Start with the simple ones like keyboard, touchscreen, and work your way up from there through all of them. So something with this is we, for Compose, don't want you to have to rely on recreation in order for everything to function correctly. So if you are trying this and you're finding issues, and that issue happens to be in Compose itself or Compose library, that is kind of expecting recreation to happen in order to function correctly, that is a bug. You should report it, let us know. We don't want you to have your activities being recreated to work properly. Another way to think about this is if you're writing Compose code that is requiring recreation to happen to function correctly, that's kind of not as correct of Compose code as you could have. So it might work fine if recreation happens, but kind of fully correct Compose code should be using all those local configuration and other composition locals to update itself in place properly. Now, I think I have time here to go through a kind of whole list of every single type of configuration change, and I'm going to give an opinion on how risky I think these are in general for apps to do. So what better way to do that than with a tier list? So let's quickly go through every single type of configuration change. And the order here is going to be roughly when they were introduced to Android. Touchscreen. This is whether or not the window is controlled with a touchscreen. So pretty self-explanatory. And this can change when the physical display changes. Like with connected displays. You plug in your phone to an external monitor. Now you might have your app running on an external display that isn't a touchscreen. I would suspect most apps don't actually care much if it is a touchscreen or not. So I'm going to consider this one fairly safe. Next, keyboard and keyboard hidden. These are the ones I was mentioning earlier. These are configuration changes that depend on the type of physical keyboard and its state. So if you have a Chromebook that's a 2-in-1 and can kind of flip around all the way where the keyboard's on the back, in that state, you will have a hidden physical keyboard, which is a configuration change, will recreate your activity, and the keyboard itself is if you have a physical keyboard at all. So both of these, again, I suspect most apps aren't caring about these, so I think these ones are also pretty safe. Locale. This is the current language and the region, and this can change when the user changes languages. This one in particular, because text is so important, and also there's so many kind of hidden ways that locale is being used, like in the time formatting, date formatting. I think this is one of the riskiest ones that you can have. You kind of have a lot of important things to deal with in order to handle this one correctly. All right, next one, MCC, MNC. This is the mobile country code and the mobile network code. If you're wondering what the heck these are, it turns out these are important for the phone part of your smartphone, actually making phone calls. And this will change when the cellular network in use changes. And these ones are interesting because these are actually in a fifth category. These are super, super safe because it turns out these already are configuration changes that by default won't cause recreation. In a certain Android version, these will actually by default now not cause recreation unless you opt back into it with another manifest tag, recreate on config changes. So these ones are super safe. Probably most apps out there are already not having recreation happen for these. So there we go, new category. Most apps are already probably doing this at least a little bit. Next, navigation. The physical navigation type. Things like trackballs, D-pad, wheel, or none. This one, if you probably have never thought about this, it's kind of a very old one, back when phones looked a lot different than they are now. You probably aren't using this at all. It's pretty safe. Next, UI mode. This is a combination of two things, whether you're in dark mode or light mode, the theme, and then also a more general UI mode value. Things like normal, which is like phone, tablet, TV, watch, desk, car, and there's some more in there too. This will change when the theme switches, which can also be automatic based on some features, based on time of day, or if the user changes the mode. Docking a device, entering a desktop mode, this can change. These ones are kind of in the middle. They're not super tricky to handle, but also a lot of things are based on this, so I'm putting this somewhere in the middle. Next, font scale. This is the factor to adjust text sizing by. Note, this isn't a linear since Android 15, so this isn't just a multiple that you can use to convert. And this will change when the user changes the font size in accessibility. This one is fairly localized to text, but is also very important to get right. So I'm putting it somewhere in the middle here. Next, I've combined all these as kind of the window size configuration values. I know it says screen in them. It is not about the screen, it is about your window. If you're in a multi-window mode, these values will refer to your current window size, not the physical display size. And these can change when your window is resized. Multi-window modes, device rotation, folding, unfolding, switching displays, density changes, all those things impact the size of your window. These ones are also kind of in the middle. Most layouts are probably already, not hard-coding pixel values and are doing measurement calculations, so I'm putting this one somewhere in the middle. Like if you're already handling different window sizes, hopefully you're also handling when that changes. Next, density. The density of the window. This is a multiplier to convert from DP to pixels, and this can change when the density of the display changes, or again, if the app is switching which display it's on. This one is really risky. I think that most apps have probably never checked what actually happens here, and this impacts literally every single pixel in your entire app of how it's displayed. So I'm putting that one pretty risky. Next, font weight adjustment. This is an adjustment to the weight of the font, how bold it is. This changes when the font weight is changed in accessibility settings. It's kind of related to the font scale of like another thing that happens with text. So I'm putting it in the middle. Layout direction, left to right, right to left. This changes when the locale changes. Since it's similar to locale in terms of how it has to handle things, I'm putting it up there with locale. Color mode. This is the color mode capabilities of the window, whether it supports wide gamut and or HDR. And this again can change when the display changes. This one is not specifically if you're currently in the mode, but if the current window environment supports it. I'm guessing most apps don't actually do anything special based on this. And also, if you are doing HDR support, you probably are doing it in a way where it doesn't actually matter which one it is. So this one's probably pretty safe. Grammatical gender. This is the user's grammatical gender. And this can change when requested by the user or application. And imagine a use case where you have multiple accounts, and as you're switching the user account, the grammatical gender might change. Again, this is related to locale, getting the correct text formatting, so I'm putting it up there. And finally, assets paths. This is the newest one in Android 16. This changes when the assets paths change, like if the background wallpaper changes. This has existed as a type of configuration change since Android 12, but you haven't been able to opt out of it for recreation until Android 16. And fun fact, because of how it works under the hood with bit masks, this will actually let you opt out of that recreation all the way back to Android 12. So that you can opt out of everything if you want to is true. All right, that's everything. Oh, assets paths, probably most people weren't using that much, so I'm putting it in safe. Okay, that was all the configuration changes. There's a lot of them. So what should you actually put in your Android config changes? And the answer I'm going to give is ideally everything, but if and only if you are understanding and keeping that promise. It is probably a better experience if you don't have to recreate your entire activity and you can handle it directly, but you have to handle it correctly. Just putting everything into Android config changes isn't a shortcut. It's not a way to never think about any of this ever again. It's kind of a new way to be writing code that is always using the current configuration value and updating it properly when it changes. And specifically, you can recompose, don't recreate. That's all I have. One special shout out here, this entire slide deck was itself built with Compose. This was using Brian Norman's storyboard. You might have seen the talk yesterday. So there's a link down here to the slides on the website, and also you can find the source for the slides themselves. I'll be around for any questions, and thank you very much.